Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments. Where tonight, it's never too early to start thinking about the end of the year, and it's coming up quickly. And so we're going to help you prepare you and your students for some end-of-year course exam success, focusing in or on statistics. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. Tonight, I'm lucky to be joined by our two panelists, Mike Kaler and Tracy Watson. Mike has been involved in the TCube program and a TCube national instructor for over 25 years. He taught high school math in the Kansas City area for 47 years, and he's a consultant for the Midwest region of the College Board. Mike's authored the one-day workshop, Developing Algebraic Thinking, and has instructed numerous workshops on integrating technology in the teaching of mathematics and instructs AP Calculus Summer Institutes. Mike, thanks so much for joining us tonight.
Thank you very much for inviting me.
And Tracy has been teaching geometry and AP statistics, as well as AP computer science principles at Benton High School in Arkansas for the past 4 years. She was introduced to the graphing calculator as a teaching assistant in graduate school and hasn't turned back. As a TCube national instructor, she enjoys sharing with teachers across the country the appropriate use of technology in the classroom. Tracy, thanks for being with us tonight.
Thanks for having me, Mike. It's great to be here.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send any questions that you might have for Tracy or Mike using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. And as a reminder, this session is being recorded, and we'll provide a link, the event certificate of attendance, as well as a link for the documents at the conclusion of this event. We hope you don't have any audio issues, but in the event that you do, try selecting Communicate from the top of the WebEx menu and choose Audio Broadcast. At this point, Tracy is going to discuss our agenda.
Okay, we're going to start off tonight with just some quick general tips that we as AP statistics teachers need to keep in mind to share with our students. And then we're going to move into some concepts that target the technology skills that our students need to know going into our the AP test. We're going to talk about type 2 error and sampling distributions, where we'll be able to look at a normal distribution and how our technology can help us find the numbers that we need to answer those questions. Then we're going to look at a 2-sample t-test for a difference between means to make sure they can answer the AP problem that we're going to view. Then we'll move into confidence intervals. And so we picked a 1-sample Z interval for population proportions to take a look at. And then back to doing a hypothesis testing, the chi-squared test. That's the one that's kind of a little bit different using our technology. And if we have time, we'll finish up with a normal distribution problem.
Thanks so much, Tracy. And Mike is going to discuss our expected outcomes.
Thanks, Mike. We're going to try and look at technology tools that involve the normal distribution in both platforms, the TI-84 and the Nspire. We're going to look, again, using both platforms at statistical inference and confidence intervals. And finally, hypothesis testing using both the 84 and the Nspire.
Thanks so much, Mike. You should have control. Feel free to share your screen.
Thank you. Well, again, welcome. And we're glad everybody could join us tonight. Before we start, there's a couple of things. As Tracy mentioned, we're going to show the technology part of the problems that we're looking at tonight, but a few important points for the AP exam. Explanations and conclusions need to be in context, always required for a complete answer. For example, the results of a hypothesis test should always be followed by a conclusion in the context of the problem. Students should know the vocabulary of statistics and use that vocabulary correctly in all written responses. Remember to define all symbols. Specifically, remember to distinguish between population and sample parameters and sample statistics. And finally, remember to state and check all necessary assumptions when performing hypothesis tests and constructing interval estimates. These might get lost tonight as we tend to, in a short amount of time, look at as much technology as possible, but it's important not to forget these as we move forward. The first question we're going to look at is the 2018 question number 6. The problem states the systolic blood pressure and the amount of pressure that blood exerts on blood vessels while the heart is beating. The mean systolic blood pressure for people in the United States is reported to be 122 millimeters of mercury with a standard deviation of 15. A wellness department of a large corporation is investigating whether the mean systolic blood pressure of its employees is greater than the reported national mean. A random sample of 100 employees will be selected, the blood pressure of each employee in the sample measured, and the sample mean calculated. Let mu represent the mean systolic blood pressure of all employees at the corporation. Consider the following hypotheses. The population's mean is 122, and the alternative hypothesis is that the mean is greater than 122. Okay, there we go. The first part of the question was you were asked to describe a type 2 error in the context of the hypothesis test. Type 2 error is when a null occurs when the alternative hypothesis is true, but the null hypothesis is not rejected. In this situation, a type 2 error would happen if the mean blood pressure of the population of employees is greater than 122, but the null hypothesis that it is 122 is not rejected. In other words, a type 2 error would happen if the mean blood pressure for the population is higher than the national average, but the test does not conclude that it's higher. Now let's move on to part B. Assume that the standard deviation of the blood pressure of all employees at the corporation is 15 millimeters of mercury. If the mean is 122, the sampling distribution mu sub x bar for sample sizes of 100 is approximately normally distributed with a mean of 122 and a standard deviation of 1.5. What values of the sample mean, x bar, would represent sufficient evidence to reject the null hypothesis at the significance level of 0.05? So we have a sample distribution with a mean of 122 and a standard deviation of 1.5. Our question is to try and find out what value of x bar would cause us to reject the null hypothesis. So we're going to use the TI-84 and look at the distribution menu and inverse normal, which is option 3. The area that we are interested in, since the alpha is 0.05, is 0.05. The mean is 122, and the standard deviation is 1.5. And we're going to be looking at the right-hand tail, since the alternative hypothesis involved greater than. Whoops, sorry about that. So the results show that a x bar of 124.467 or greater would cause us to reject the null hypothesis. Let's move on to part C. The actual mean systolic blood pressure of all employees at the corporation is 125 milligrams of mercury, millimeters of mercury, not the hypothesis value of 122, and the standard deviation is 15. Using the actual mean of 125 and the results from Part B, determine the probability that the null hypothesis will be rejected. So, the blue graph on our screen shows us the null hypothesis, mean of 122 and a standard deviation of 1.5. We just figured out that the value which will cause us to reject the null hypothesis is 124.4675. Anything greater than that would cause us to reject the null hypothesis. The next graph that I've demonstrated here is the fact that the actual mean is 125. And we're interested now in what's the probability that we would have a value of a mean that's greater than 122.4675 based on the fact that the mean of the population or the population of employees at the company is 125. So we're looking for this area. Again, the mean of the red distribution is 125. Using again the distribution menu, we're going to look at the normal CDF of this curve. Excuse me. The lower value is going to be the value we were looking for, which is 122.467. We want, we want the area to the right of that, so the upper limit would be infinity.
Mike, you want 124.
I'm sorry. I knew I'd, thank you.
Yeah.
Way to keep track of me. All right. The mean, now this is what I would tell the students is the truth. This is what's really out there. So the actual mean is 125 and the standard deviation is 1.5. The results is 0.6387 and a few more decimal places. So again, this is just kind of a picture of what we've done. We found the area of the red region underneath the curve whose mean is 125, and the area turned out to be 0.63. And then the final question is, what statistical term is used for the probability found in Part C? And this is the power of the test. So that kind of concludes the discussion with the TI-84. So I am going to let Tracy show you what's happening with the TI-Nspire.
So I'm going to take the same problem that Mike went through and just target those technology pieces so that you can see how it's done on an Nspire. And so I'm kind of not going to go through the whole problem again, obviously. I'm just going to target those technology pieces. So the first time he picked up his calculator was to use calculate the inverse normal so that you find the value of your sample mean where you would reject the null hypothesis at a significance level of alpha of 0.05. And so on an Nspire, I have a calculator page already started, and that's usually where I do most of my work, calculator page and lists and spreadsheets when I'm doing AP statistics. And under the menu, I'm going to go to statistics, distributions, and then that's where I will find the inverse normal option. Now, here is one difference between the 84 that Mike was using and the Nspire that I'm using. notice on my options, I don't have the choice of doing a left tail, I think it's center tail or center or right tail. I just remember the left and the right, and there's an option in the middle. I don't have that. So I always have to, the area I'm going to give is always a left tail area. So in this problem, since my alpha is 0.05 and my null hypothesis is in the direction of greater than 1.22, or my alternative hypothesis, sorry, the area I need to type in is 0.95. So if you use an Nspire, that is one difference. The students get used to that. It's not a big issue, but they just need to know that it's just a little bit different. And then I'm going to give my mean and my standard deviation. Click OK, and I get, thank goodness, the same number that Mike got, 124.467. That would be bad if I didn't. Okay, so that was his first part. And again, the only difference is the area part. I have to always answer my questions in terms of the left tail. And so that's why the drawing the pictures is important for my students to keep that in mind. Now, the second part of the question was finding, okay, the truth is actually a center of 125 now with a mean, a standard deviation of 15. And so I want the probability that the null hypothesis is actually rejected. So it's the red area that I'm trying to find. And so same thing, I'm going to go to Menu, Statistics, Distribution, and I'm selecting the exact same options that Mike did, the normal CDF. And my questions are exactly the same. The screen just looks a little bit different on an Nspire. My lower bound to get my area that's in red is 124.4675. Now for upper bound, I know Mike did something. I just tell my students, put in a really big number. So I'm just used to them doing 1 and then a whole bunch of zeros. So that's just my really big number. We know it's never going to ever get that big, but that gets us the whole way, the area to the right. And then now my mean this time is the actual mean of the red curve, 125, and a standard deviation of 1.5. And hopefully, again, I will get the same probability, and yes, I do. 0.6387, exact same number as Mike did. So you can see that if you're on the 84 platform or the Nspire platform, they are very, very similar. It's Nspire, you go to Menu, your options will be there. The 84, Distributions menu from a button. So it's very, very similar. So now we're going to turn to doing a hypothesis test. This is always exciting. My students, after we really get into these, they actually like doing these. They say they're very long and they take a while to write up, but they don't mind doing them. So here we've got some data. I'm not going to read through the whole question. This is data about ACL surgery. And there's a new surgical procedure that they're trying to see if it made a difference. So we've got our data here where there is the type of procedure, we've got the standard procedure, and then the new procedure. And we have summary statistics. We don't have the individual's data, but we've got summary statistics about the two groups of people. And so our big question is, do the data provide convincing statistical evidence that those who receive the new procedure will have less recovery time from the surgery on average than those who receive the standard procedure for patients similar to those in the study? Okay, so when my students see that question, do the data provide convincing statistical evidence, they know we're running a hypothesis test. Okay, that's kind of their trigger. Now, the next thing I have them do is make sure you think about what test you're going to be running and make sure you state your null and alternative. And when you're doing that, as we said at the beginning, make sure they define all of their variables. So here is my null and my alternative that I'm going to go with, stating what my variables, And I'm going to be doing a 2-sample t-test for a difference between means. So this is what I need to ask my calculator to do. With this information, hey, run this test for me. So I'm going to go grab my calculator again. I'm just going to do this so we have a clean page. Okay, so I don't have that other stuff on top. And to run a test, I'm going to go to Menu, look under Statistics, and lo and behold, there is a Stats Test menu. It's funny how long it takes my students to find that menu when we've been doing the old-fashioned way distributions for a while. And then they get thrilled. Okay, so what we're doing is a 2-sample t-test, and that's the name of it on the menu. Now, the first question it's going to ask me, you've got data, how are you going to give it to me? The calculator wants to know, am I giving you the data or am I giving you the statistics of the data? The stats is the summary statistics, which is what we have in our problem. So I'm going to give it the stats, and then it's asking me for the information that's on the table. This is what it needs to do a 2-sample t-test. So my X bar 1 is going to be 217. My standard deviation for my first group, which is my standard group, is 34. The sample size of the standard group is 110. For my second group, the mean is 186. Standard deviation of 29, and I only have 100 of those. Now, I'm tabbing to get down to each item. And then the other thing it needs to know is, what is your alternative? How are you comparing these means? And so I am doing, where my first sample was my standard, I want to test the alternative where I greater than my second. There is this pulled here, but I just never change it. Just always leave that pulled saying no, just so you know. There is another option there, but it's not modified in my class. So when I hit OK, it gives me everything I need. And I'm going to scroll up a little bit. The meat of your information for them to actually record, you teach them everything that they need to write for a statistical test. The big things they're going to need to pull from this is their T, their p-value, degrees of freedom. I have all of them putting that on their paper in a certain format. I mean, they're used to actually the layout that I'm doing my problems, but these are the numbers, essentially, that they need to pull out. And then, of course, we even put the conclusion on here to make sure that they conclude in context of the problem. Now, this is not the layout that I do for my students, but this is the items that I get off of the calculator. So once I run the test, I have all those numbers, and the students know where to put them. So now what I'm going to do is I'm going to pass this back to Mike so that you can see how it's done on the 84. And hopefully it will be similar. I kind of know the answer to that question, but that's one of the things I like between these platforms. You're kind of getting to see the problem twice because there's such a similarity in the formats.
Okay. Welcome back to me. I am sorry. Too many screens fighting for space here. Okay, let's clear off this screen so we get kind of a fresh palette. Again, this is
Mike,
really simple. Pardon
me?
Can you make sure you're sharing your screen?
Okay, I thought I was. Let me go back and check that out. There we go. I apologize.
Okay. Thank you.
Okay, so we're kind of back to the same problem. It's just let's take a look at what it's going to look like on a TI-84. So computer is not cooperating tonight. Again, here are two hypotheses, just like before, and we're going to do a 2-sample t-test. On the TI-84, we go to the Stat menu, I better bring the 84 up so you can see it. There we go. So we're going to go to the Stat menu. And in the Stat menu, there are tests. And we are doing a 2-sample t-test, which is number 4. We're going to enter the statistics again. And X1 bar was 217. And you can keep track. Oops, let's try this again. Okay, 217. Standard deviation was 34. Sample size. Okay, I am definitely off somewhere here. Oh, boy. Excuse me. Let's try this one more time. Maybe we can get it right this time. So, stat, test, 2-sample t-test. There we go. All right. So, mean was 217. Standard deviation, 34. Sample size, 110. Now we go to the other, and mean was 186. Standard deviation was 29. And the sample size was 100. This was a one-tail right test. So we want to see if mu1 is greater than mu2. And again, we're not going to pool. And oh, that's right. There's more stuff to do.
Do you want
on this you have the choice of either calculating the answer or drawing the answer. Since we calculated it on the Inspire, I thought it might be interesting to see what would happen. Oh, let me go back and change that pooled. Okay, and change it and see what it looks like if we try and draw it this time. Oh, I've got all that other stuff from before. I apologize. Forget the red and the blue one from before. The one that we're talking about is this one, but it's back on another screen. So that was a bad idea. I thought I'd do something different. Let's not do that. So
that is pretty cool, though, Mike.
Oh, yeah. It sure looked great. So real quick, this will just take a second because when you go back, everything should still be there from before. And this time we'll just calculate it. And again, we'll get what Tracy got. The same thing. We have a t is 7.12 with a p-value so small that it's essentially 0, 207.179 degrees of freedom. And those are the main numbers that you need to report your answer for the AP exam. And so there's the t-statistic, there's the p-value. It's very small, so we have sufficient evidence to conclude. And again, notice that this conclusion is in context. That's what the readers on this AP exam are looking for. Tracy, have there been any questions or anything over the last few minutes?
I haven't noticed anything about.
Okay. Then let's move on to the next question. This comes from the 2017 exam. It's about a manager of a local fast food restaurant who's worried about people getting a water cup and then filling it with soft drinks. And so he decided to do a small test, and he took a sample of 80 customers. And he kept an eye on them and found out that 23 of the customers filled with the soft drink from the beverage fountain. So the question was to construct and interpret a 95% confidence interval for the proportion of all customers who have asked for a water cup when placing an order And will they fill it with a soft drink from the beverage fountain? So this was the question to construct and interpret the interval. Again, remember it's a random sample. It is a large sample. Students should check the n times p and n times 1 minus p. They should not just write this down. They need to give the actual numbers that they would arrive at by checking this. Those numbers are 23 and 57, so they are going to be greater than 10. But I think it's more than just a routine. You need to actually show evidence that those numbers are bigger than 10. And we're going to do a one sample z interval for a population proportion. So again, we're going to the stat menu. And this takes a little bit of looking. We go over to tests. And you can go down or up. It's about the same because it's right in the middle. So I went up arrow, and we are at a one proportion z interval. The x was 23. The number was 80. The confidence level was 0.95. So we'll calculate the interval, and it's between 18, almost 19%, and almost 39%. So somewhere between 38 and, or 18, 19, and 38% are going to take advantage of the restaurant and get a soft drink. So the answer we'd want to give on the exam is something along the lines of we can be 95% confident that in the population of all customers of the restaurant who ask for the cup, the proportion that will fill it with soft drink is between 18 and 38%. So then we come to the next part of the question. And supposing that in the month of June, 3,000 people asked for a water cup, and a soft drink costs the restaurant 25 cents. So they want you to use the confidence interval that you just had on the last part of the question to give an interval estimate for the cost of the restaurant for the month of June from customers who ask for a water cup, but fill it with a soft drink. So as we get ready to do this, let's clear this off so we get a fresh screen again. I'm going to start this a little bit differently with the variables menu. And there's a lot of neat stuff buried deep in these calculators that sometimes it's maybe more trouble to get to, but I thought this was kind of interesting. So in the statistics menu, way down at the very bottom, test, there we go. Way down at the very bottom, there are two variables. One's called lower and one's called upper. If we take the lower interval, or the lower value, I'm just hitting it to show what happens. It's the low value of the interval that we just found. So to answer the question, if 18% of 3,000 people use the cup to get a soft drink, and those soft drinks cost the restaurant 25 cents, they would lose, potentially on the low end, about $141. To find out the upper end, you can do the same thing, variables, statistics, and then go to the test menu. Oops, I am so sorry. There we go. And we're going to pick the upper, and I won't show you. It's going to be the same number as 0.38668. But again, multiply that times 3,000, and then multiply that times 25 cents, and we end up with about a $290 loss. So the restaurant stands to lose anywhere from $141 to $290 if customers take advantage in the same proportion as his sample showed. So with that, I will turn this back to Tracy and let her show you the similar thing on the 84, or excuse me, Inspire. Mm-hmm. And I have stopped sharing.
And to give pass control, yep.
Yep, you've got control.
So we're back to it. Now, I do have a question for you, Mike.
Well,
I'm going to clear my calculator. I'm going to get a new page just so I have a clean page. I like a clean page every time I start a problem. When you're doing, because I'm big on making sure my students show as much work as the AP people might like. And so when you're doing your conditions, I do the random and the large sample size. Do we need to do the independence condition on this also? Mention that?
Yes, probably should.
Okay. Because that was one thing on there, because my students, I harp on that of doing, all possible conditions, even though I know sometimes the rubrics don't check that one a lot of times, but I'm just too scared to not have them do it.
Right. And again, I think the key is not just to make a list of them, but to actually do something with that list.
Exactly, yeah. I have them do that random and problem states random, the large sample size, and plug the numbers in. Right. And then for the independence, I kind of talk to them. It depends on the problem. To me, the approach is one customer influencing the other or using that 10% condition thing.
Right.
And I kind of sometimes, I'm not sure which one AP would rather have, so I don't know if you have any thoughts on that, on this problem.
I really don't.
Okay. I tell my students, if you're not sure, just do the 10% condition. So at least they know you've thought about that independence. Okay, so I'm going to do the same problem. I tell you, I love this problem because I know I get water when I go to Subway. And I always wonder if, and I'm honest that I just get the water, but you have to go to the soda machine to get the water. So it kind of looks like I'm trying to cheat them, but I'm just hitting that little button. So that's why I think this problem was really interesting. But my first job is to get the same confidence interval. So I'm going to keep my fingers crossed that with the data, I think I have all the data I need on my screen from the problem, that I get the same confidence interval. So again, there's such a similarity between the two platforms. I'm on Nspire, so I'm starting off hitting menu, and then I'm going to statistics, and wow, there's a confidence intervals menu that opens up. And just like Mike did, I'm going to select the one sample Z interval, no, never mind, sorry, one prop Z interval in order to do a proportion, a Z test. And it gives me the questions that I need to do the calculations. So that's why on my screen I left that 23 out of 80 and I put it in red. In the sample that we saw that they observed, there were 23 successes, which in this case means they filled their water cup with soft drink, but we're going to call that a success. That always bothered me about this problem, but that's okay. And I had 8 people that I watched, and I'm doing a 95% interval. And when I hit OK, boom, I'm done. I've got everything on my screen that I need. Now, again, the write-up is different. I have my students showing how it was built, so showing the important pieces to convince someone that they're more than just button pushing, that they actually know what they're doing. So hopefully you've got that process, what numbers they pull out of this and what all they should be showing. The the bulk of the answer is my lower and upper bound are the same as Mike's, thank goodness. I've got my p-hat there that I have students show. My margin of error, that calculation, that plus or minus part is there. So I do have students show that before they give their final answer. But then again, big time, write the answer in the context of the problem. That is so, so important. Okay, now the other part of it, don't want to move that. Let's go to this part. Let's see if I can get the same answer for, okay, we have these people that are not being honest, even though, again, probability of a success. How much is it actually costing the business if this is what the range is of the truth of people who are putting soda in their water cups? So similar to Mike, once I run a statistical test, the calculator knows all of these values and has them stored. And on an Nspire, to pop anything up that was automatically stored when you're doing processes, you just hit your var button. Now, I immediately then see stat dot, stat dot. These are all of the variables that were resulted from running the statistical test or doing statistics, okay, of the last test that I did. If I run another test on the same page, the values will change to the current test. So I'm going to go to stat C lower. That's the lower end of, oops, I did upper. So we're doing upper first, sorry. And to figure out, let's see, it was 3,000 customers and 25 cents. And so I do get the same upper bound, $290 and a penny. And then stat and now let's actually do the lower value. And if we want, I can show you that it does equal that value like Mike did. But what I really need is that number. So I do get the actual same values. Now, this problem I actually just gave my students this week. And so one of the things that I reminded them, and it reminded me when I was looking at the rubric, they have to show their reason for this answer. In the rubric, to get all the points, to get all the E's and everything, they have to indicate how they came up with those numbers. So don't forget to tell your students to show their work. Even though this is just simple arithmetic, the AP want to see where those numbers came from. So I just thought I'd mention that because I was just in that rubric actually yesterday getting stuff ready for my students. So we're going to move on to the next problem.
Hey, Tracy.
Yes.
Sorry, before you do, we actually had two questions that I was hoping we could answer. One's from Meg. This is going back, and she said, I know it's not a calculator-related question, but for the Z interval, do we also need to state 80 customers less than 10% of all customers?
Yes, like that was the question about the independence condition that I referenced while we were switching over. That
Perfect.
Let me, in addition to those two conditions of random sample and large sample, we should do independence. Even though a lot of rubrics don't target that, it's always a good idea.
Great. And then the second question is from Aaron. Is it important to the AP graders that our students list the p-hat, the point estimate?
I don't have a definite answer for that, but my students better.
Yeah, I would suggest yes.
Yeah, and that's nice that it gives it to you. That's why I usually have them record this also. My students write a lot more than what the calculators give me. I make sure that they actually remember how to calculate the margin of error if they had to. So they actually have to show all of that work. So.
Thank you.
Yeah. So let's go to the next problem. Actually, while we mention that, one of the things you're going to have access to is a handout that was put together where we have the screenshots of our calculators answering these questions. And on the Nspire one, I actually put some of my handwork in there so you can kind of see some of the work that I show related to the calculators. So that might, show you a little bit. I don't have the full problem worked out, but just those pieces. So, but I thought you might be interested in that at this point. Okay, so I'm going to go to the next problem, question 5 on 2017. Again, I'm not going to get into the problem. I'm just going to jump into the bulk of it. It's a statistical test again. This one is a chi-square test of independence. So this one is very different. Got to check all of your conditions, randomness, expected counts. This one, you need to have all your expected counts at least 5. And so this is why this one, before I even do this problem, I actually go to the calculator, because when I'm doing conditions, I don't require my students to do the expected counts by hand. I show them where it comes from, but the calculator does that for me. So I'm going to quickly throw another page. And when you're doing these, I have to give the calculator this two-way table information. And I do that by using a matrix. So I'm going to hit my math template bar, and I have my generic matrix selected already. And I'm doing a 2x4 matrix is what I need to give to the calculator. And so I'm typing in the numbers that the problem gave me that I'm going to try and run a test on. And to make sure the calculator keeps this and knows what this matrix is for, I need to store this as a variable. So in Nspire, I hit Control-var to store. This is the observed data. So I usually have students typed observed or just OBS as the name. That way they clearly know that that's their observed data. And so now that's all I need when I'm running a chi-square test of independence. So I'm going to go ahead and run it. Menu, statistics, statistical test, of course. And there are 2 chi-square tests. We're doing a two-way test. This is the one where your data is in a matrix, because that's the first question is asked. What is the observed matrix? So I just hit the right arrow, and I already have the matrix there. And now I have all of my information. I've got my value for chi-squared, my p-value, my degrees of freedom. Now here it doesn't show my expected matrix, which is what I need to report for one of my conditions. But if I hit var, notice how my variables have changed, and I have a stat dot expected matrix. That's where students go to actually see the expected matrix. And they can record that down when they're checking their conditions. And then the test gives me all the information that they definitely need to have when they're answering this question. Again, I just pulled out the big stuff for it. And then, of course, we're rejecting the null, and they got to write a conclusion in context. Okay? So that one's a little different because of having to do the matrix stuff. So I'm going to pass it back over to Mike so he can show you how that is done on the Nspire so that you can see if there's any differences. Or, sorry, on the 84, Mike.
That's okay. I knew what you were talking about.
Hopefully everybody did.
Okay. Let's take a look at the same problem. Won't go through all the explanation and so forth. Just jump right into the calculator. Let's see. There we go. And let's clear everything out. Okay. Well, again, the first thing you need is a matrix.
Share your screen.
Am I not showing it?
I don't see you yet.
Oh, boy. I thought I had this all taken care of. Oh. All right. I guess I just go too fast. I'm so excited.
There we go. Yep.
All right. Let's see. All right. So the first thing we're going to have to do is enter our matrix. And on the 84, there is a soft key right above the X inverse key, which is the matrix. The first thing we're going to do is edit. So we go over to edit, and then we're going to enter a 2x4. I didn't know if we were going to have time or not, so I went ahead and put the numbers in ahead of time. So there we have it. I edited matrix A. So we now have our data in matrix A. Just to make sure, if we go to the matrix menu again and I simply call up matrix A, there it is. And we can double check to make sure we have the right data. Excuse me. So we're now going to run the test. And this is a chi-square test. Matrix A is where my observed values are. You can pick any of the matrices that you want for the expected values. Just to show you how that would be done, I'm going to go back to the matrix menu. And let's go down and we'll pick E5 for expected. So you see, that's all they have to do to pick a matrix to have the data, the expected values put in. And we will calculate the value. And there's the chi-square value, 10.883. P-value of 0.0123. And 3 degrees of freedom.
Nice.
And now, to see what our expected values were that you would need to report, again, simply go to second matrix. I'll go down and pick matrix 5, which was E. And you could cut this down if you were doing this in class and didn't want all these decimals. You could cut it down to, in the mode to, 2 or 3 decimal places, and you would see it better. But you can still scroll across and see that every one of the numbers are all greater than 5. And looking at, go ahead, Tracy.
I actually like that you called it E for expected.
Yeah, I think that's a good deal. I always did that in class when I was running through this practicing. I just did B because it was easy, but I usually do E with my students.
Nice.
I'm looking at the clock, and it looks to me like we're not going to have time for the last question, but it will be in the handouts, and both of our screenshots are up there. It's a relatively simple problem on, what was it on? Oh, a normal CDF, a normal distribution problem, which is kind of like what we did with the very first problem, so I'm sure you'll be able to handle it from there.
Yeah.
And I guess, Mike, you want this back now?
Sure.
Okay. I don't know if there are any questions outstanding that we need to look at or answer at this point.
Well, if there are, that was actually what I was going to bring up. As we begin wrapping things up, if you do have any questions that maybe you haven't asked yet, or maybe I had missed earlier, please feel free to ask those again. I know Mike and Tracy will try and get those answered in the last few minutes we have here.
I think one of the takeaways that I just want to make sure, remember, we were just targeting how to use the calculator that is supporting the work that you do in your class, and, being clear with students about what they need to show so that they're showing understanding is huge in our classes. So, but the calculator does the grunt work for us. That's what I tell my students. But we got to know what it's actually doing with that stuff.
Thanks, Tracy. So we're excited that the T-Cubed International Conference is coming to Baltimore here in just a few short weeks. If you have a chance to attend, you'll probably be surrounded by a lot of like-minded educators who are passionate about learning more about technology and reconnecting with other colleagues, learning more about pedagogy and content and technology. It's by far my favorite conference of the year, and I'm pretty sure that both Tracy and Mike will be there, and if I had to guess, probably presenting some sessions and definitely attending some sessions. So Please feel free to learn more about the conference by visiting our website, education.ti.com, and we hope to see you there. Leading up to the conference, we're also engaging in a slow chat book study. So I put the link in the chat window of the book that we're going to be reviewing. We actually started looking at the book last week, but each week we kind of take a small section of this book and talk about things on Twitter. So it's really easy if you happen to, for instance, not see the book until now, to get caught up, especially on Twitter, and see what people have been saying. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback guides us as we plan future online events, and we definitely listen to your thoughts. We really hope you'll share them in the post-webinar survey. To receive a certificate of attendance for tonight, please go ahead and click the link. Also listen to the chat window. There's also a link for the documents, as both Tracy and Mike had said, with lots of good stuff in their documents folder. So please feel free to visit either of those links for the certificate or the documents. And for any reason, if those aren't working for you tonight, just hang tight. You'll automatically get a follow-up email in a couple days. And that follow-up email will be links to the recording, links to the certificate, and documents as well. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. Lastly, if you're in the need of any post-webinar follow-up, feel free to give us a call at 1-800-TI-CARES or send us an email at ti-cares@ti.com. Thanks so much, Tracy and Mike, for everything you shared tonight. I really appreciate it.
Yes, thank you, Mike and Mike.
Thank you, Tracy and Mike. Glad to do it.
I've been wanting to say Mike squared all night. I got to say it.
And thanks, everyone, for joining us. We hope to see you back online real soon. Have a great night.